look at the answers around the room for number 1. We've got false, 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 false. Great. Everybody agrees this is false. What is x cubed times x to the 4th actually equal? X to the 7th. Yeah, when you're multiplying like bases, you add the exponents. This is actually x to the 7th. Okay. So this one was false. False. Okay. If 6.2, actually, let's see, 6.2 is multiplied by 10 cubed, then the decimal point moves 3 places to the right. If I go around the room, we've got true, 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 true. That's right. True. 21 root 2 plus 10 root 2 equals 31 root 4, which is 31 times 2, which is 62. All right, let's see. We've got false, 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 false. True. I mean, true, it's false. Correct, it's false. What is 21 root 2 plus 10 root 2 actually equal? 31 root 2. Think of the root 2s as like apples, right? If that said 21 apples plus 10 apples, you'd have 31 apples, not 31 apples squared. Right? So this is actually 31 root 2. So that one was false. Okay, so number 4, 4x squared minus 1 quantity squared equals 16x squared plus 1. So number 4, we've got false, 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 false. All right, very good. It is in fact false. How would I actually have to do 4x squared minus 1 squared? How would I get an answer for that? It doesn't equal this. What does it equal? Oh, does it equal 16x to the 4th plus 1? No. Yeah, you'd have to actually do a little like FOIL. When you're squaring something, that means that thing times itself. And then you'd have to do FOIL or distribute, right? So you'd get 16x to the 4th minus 4x squared plus 1. Good. All right, number 5. So I've got this rational expression here, 24x squared times y to the 13th over negative 2x to the 5th times y to the negative 2. Does that equal negative 12y to the 15th over x cubed? See, number 5, we've got true, 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 and true. Good. It is true. Okay, so we had to remember rules of negative exponents. When the baby's crying, you have to either pick it up or put it down, right? A negative exponent is like the crying baby, and you just move it to the numerator or the denominator to make it happy, make the exponent positive. So 24 over negative 2 gives me the 12 and the negative. X squared over x to the 5th, I would subtract. I have like bases, so you subtract the exponents. 5 minus 2 is 3, and the bigger one's in the denominator, so that's where it goes. And then I have got a crying baby here, y to the negative 2, move it up to the numerator to make it y to the positive 2. So y to the 13th times y squared would be y to the 15th. Everybody remembers those rules now? Okay. All right, now number 6 was definitely the trickiest one, in my opinion. Let's see what we've got for number 6. We've got false, 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 false. Wow, you're all correct. I helped some of you, but not all of you. That's really good. Let's do number 6 together. So 2/7 to the 0 minus 32 to the negative 2/5. Okay, good. So what is anything to the 0? 1. Okay, so that part's not so hard, right? 1. So I've got 1 minus 32 to the negative 2/5. We have a negative exponent, crying baby, right? Needs to be put down. So we put it in the denominator of a fraction. So this becomes 32 to the positive 2/5. And then when you have a rational exponent, that is an exponent that's a fraction, the number on top is the power, and the number on the bottom is the root. Okay, and you can remember because roots belong in the cellar. Okay, so this is 1 minus 1 over 32 to the 2/5. 2 is the exponent, 5 is the root. So this is the 5th root of 32 squared. So the 5 is the root and the 2 is an exponent. So then figuring out the 5th root of 32 is a little bit tricky unless you do a lot of like computer stuff, because then that you work with powers of 32 a lot in computers, like 32, 64, 128, those numbers you might see like in memory of a computer or something. I don't know anything about it. But all right, so the 5th root of 32. We're trying to think of a number that when you multiply it by itself 5 times, you get 32. 2. Yep. So this is going to be 1 minus 1 over the 5th root of 32 is 2 squared. So this is 1 minus 1/4, which is 3/4. So that one used a lot of rules. So it's good review for us. All right, number 7, x squared plus x squared minus x squared times x squared. 2x squared minus x to the 4th. Let's see, we've got true, 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 false, true. So when you add things, like when you're, this is also considered combining like terms, right? 1x squared plus another x squared does give you 2x squareds. And then here, you're multiplying like bases, and when you multiply like bases, you add the exponents, right? So this is actually true. So this is my 2x squared, and this is x to the 4th. Okay, root 50 times root 6, does that equal 10 root 3? Number 8, we've got true. False. True. False. True. False. Wow, we're evenly split here. Root 50 times root 6, so we should definitely do this one together. Am I allowed to do this? Yes. When you're multiplying radicals, you can just multiply the stuff underneath. When you're adding them, you can't, but for multiplying, it's allowed. All right, so then I ask myself, is there a number that's a perfect square that divides into 300? 100. So this would be rewritten as square root of 100 times 3. Right? But then what's the square root of 100? 10. So you end up with 10 root 3. So that comes out true. Yeah, that is, I think that's a faster way. You could also try to do the simplifying from the very beginning. So I'll do it that way just because I know some people were doing that. So if I have root 50 times root 6, we'd say, well, root 50, is there a perfect square that goes into 50? 25. So I would write this as the square root of 25 times 2 times the square root of 6. Square root of 25 is 5. So this is 5 square roots of 2 times the square root of 6. Now I use the rule where I can multiply radicals. So this becomes 5 times the square root of 12. Is there a perfect square that divides into 12? 4. So I could rewrite this as 5 times 4 radical 4 times 3. But the square root of 4 is 2. So this becomes 5 times 2 times the square root of 3, which is 10 root 3. Same answer, right? A little bit, few more steps. All right, so that number 8 actually was true. Okay, 3x plus 5 minus the quantity 4x minus 7 equals negative 1x minus 2. We've got false, 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 true, false. Okay, so we have to distribute that negative before we can combine like terms. So this is 3x plus 5 minus 4x plus 7, right? So you have to distribute the negative sign. And then combine like terms. 3x minus 4x is negative 1x. And 5 plus 7 is 12. Yeah, so this is actually negative 1x plus 12. So this is false. So you had to distribute that negative sign to get that one. All right, so people feel like, oh yeah, I'm starting to remember some of these rules. Okay, coming back slowly. Okay, so if you haven't already, we've got 10 minutes left, so work on this little group activity here where you just do a little bit more practice. You have the answers down at the bottom, and in case I forget to point out, the next page after that is where I write down your assignment and what you should do for next class and all that stuff.